Okay, so this last video is where the big punchline comes in, and this is actually why it's so important and why we're doing the things we're doing. Alright, so we're going to be given an angle. Based on this angle, realize that we have the hypotenuse. Well, we don't have it, but there's the hypotenuse, there's the adjacent, opposite, and adjacent sides. So, based off this angle, opposite and adjacent. Which trig function uses O and A? Well, that's tangent. Alright, so given the two side lengths 17 and x, we need to use tangent. Those are opposite. Tangent of theta equals the opposite side over the adjacent side. And then all we're going to do is plug in the known information. We're going to say tangent of angle 31. Instead of saying theta or x, now we can actually say 31. And the opposite is 17. And the adjacent is x. So that's it. This is a big punchline. Alright, now what students like to do, what's going to lead to more success and familiar what we've been doing in this class, is tangent of 31 is just some number, so we're going to treat it as just some number when we're solving for x. I'm going to put it over 1. It's going to remind students that all they need to do is cross multiply. Alright, and this is brand new. Write this exactly how I write it. Write it exactly how I write it. Tan, or x of tan 31 equals 17. Now remember, tan 31 is just some number, so it's x times some number equals 17. All you got to do to solve for x is divide both sides by that number. Alright, now we could plug in tan 31 immediately, but we want to wait till the very end because it's going to reduce rounding errors. If you plug it in immediately, as you saw before, you get crazy decimals and it's just harder to deal with. We're going to wait till the very end. So x equals 17 divided by tan 31. So in my calculator, I just got to do 17 divided by tan 31 and then hit enter. And boom, 28.3. It says rounded 2 decimal places, so 28.29. That's it. So that's saying that given an angle measure and an opposite side, we can figure out the adjacent side is 28.29. Think of all like roads can have slants, and you need to know horizontal distances, roofs, ramps, construction. This stuff's very useful. Okay, so that's your first trig problem we did to find an unknown length. That's pretty cool. And this is a huge punchline. This is stuff we're going to be doing a lot the rest of the unit. So this is very important, so make sure you know what's going on. So similar, we got this one now. We got 32. Alright, 20 is always the hypotenuse, the opposite side's over there, that's the adjacent side. Well, in this case right here, we have adjacent and hypotenuse. Which trig function uses this? Well, I can even write this right here. We have SOHCAHTOA. SOHCAHTOA. Which one uses adjacent and hypotenuse? Well, in this case, that's cosine. So cosine of theta equals adjacent over hypotenuse. Now I'm just going to plug in all the stuff I know. It's going to be cosine of 32 equals x over 20. So notice how in this case now, like in the previous example, x was in the denominator with 17 divided by x. Now x is in the numerator. It's just dictated by what side lengths you have, which trig function you're using, so on and so forth. Alright, put that over 1, cross multiply. We're going to get x equals 20 times cosine 32. So this is a little bit nicer, a little less calculations, not too much more. Oops, didn't mean to do that. So then just be very careful when you plug this in your calculator. 20 cosine 32 equals 16.96. That's it. Alright, this is brand new. This kind of seems funky, maybe a little bit scary, but trust me, as we progress, we're doing this for a few days, you'll get really good at it. Then this one right here, given that this is 65, or we have at angle, hypotenuse, adjacent, opposite. So this time we have the opposite and hypotenuse. Which trig function uses opposite and hypotenuse? As we progress, you'll immediately know it's the sine function. So all you got to do is write, well, we'll be a little bit more specific. Sine of theta equals the opposite over hypotenuse. So sine of 65 equals the opposite 17 over hypotenuse x. And then just cross multiply and solve. Then we got to divide both sides by sine 65. Remember, sine 65 is just some number. When we're solving this, we're treating it as just some number. Kind of ran out of room. So x equals 17 divided by sine 65, which is approximately 17 divided by sine 65, enter, 18.76. All right, so that's it. Those are 3 classic trig problems. All right, now let's dive in the next video and do a couple more. Actually, we'll just knock them out super fast. Tricked you, plot twist. All right, so this one right here, all right, will be a little bit more quicker. We'll practice these in great detail. Let's find y first. So again, I have 35, adjacent, opposite, hypotenuse. All right, so to find y, we're going to do cosine of 35 equals y over 20, because cosine of theta equals adjacent over hypotenuse. All right, cross multiply, we get y equals 20 cosine 35. Plug that in your calculator, and it's going to be about 16.38. Cool beans. And then what's nice about this is if we know 2 sides, we can use Pythagorean theorem to find x. That's mathematically legal. You're allowed to do it. However, let's just do trig because it's brand new and I want to get good at it. So now with respects to 35, well, we can use tangent or sine. I'm going to use sine this time. I'm going to use sine because x is the opposite side and we have the hypotenuse. So this time I'm going to just do sine of 35. Opposite's x, hypotenuse is 20. Put that over 1, cross multiply. We're going to get x equals sine, or 20 sine 35. And in this case, it's about 11.47. Okay, cool beans. 2 trig problems right there. Find the height of the lighthouse to the nearest foot. So again, boom, given that that's 62, we have the opposite side, we have the adjacent side, and SOHCAHTOA, which one uses opposite and adjacent? Opposite and adjacent would be tangent. Tangent and SOHCAHTOA uses opposite over adjacent. So tangent, remember I made up SOHCAHTOA to help kids remember which trig function to use. All right, you guys might be scared, but don't worry, you guys are gonna be so good at this eventually. I actually think this is one of the easier things we do the whole unit. So it's about 188.07. So this is another case where you can use trig to find heights of things. You can find the trig of the lighthouse. If you look up at a 62-degree angle, that's easy to measure. You know you're 100 feet away. You can figure out the height of the lighthouse. All right. And a strange man is kayaking in a lake observing 2 geese. He's staring at one of them at a 50-degree angle of elevation, and his eyes are 4 feet above water. He knows that the geese are at a horizontal distance of 30 feet away. How high above the water is the goose's head? This strange man, this is actually me. This is me kayaking, and I was looking at some geese. And then my father-in-law snapped a picture right when they flew past me. Wow, I'm so good at kayaking. Nonetheless, all right? So this is this basic problem. We're just adding in just another layer. So with respect to 50 degrees, we have the adjacent side. We need this right here, which is the opposite side. And if you really want to know something, I think tangent is the most useful in the real world. Not that cosine. Cosine and sine, incredibly important. I would just say tangent is more important than those two. So setting it up, we get this. And then we're going to cross multiply. I don't know why I chose yellow. That wasn't a very good color to pick. So let me switch. We're going to get theta or opposite equals 30, tan 50. Which is about 35.75. That means at this height, the goose's head to my eye level was 35.75. So that's total height is what we want. This total height will be 39.75 because we're just going to add the 4 other feet. All right, so that's it.